Hi, today I want to show you how you can create your own sysfs class interface. So yeah, there are some popular examples for sysfs class interfaces, and one is the LED interface. So if you navigate under sys class LEDs, every LED which you have added over the device tree has its own folder. For example, this is our activity LED, and if we take a look what's inside this folder, activity, you can see there are multiple files and folders in it, and when we're writing to these files, what we're really doing is we're calling a callback function in the corresponding LED driver. And for example, if we would write a value to the brightness file, we can change the state of the LED. And in today's video I want to show you how you can create your own sysfs class interface, so how you can define your own class and create own folders and your own files in it. So that's basically the topic for today's video. Okay, so let's start. First, let me navigate into my Linux driver tutorials folder, and here you can see all the various drivers I've already created. And I will use the simple Hello World kernel module as a template for today's video. I will create a new folder 37 and I will call it sysfs class. Okay, and then let me navigate into it. And let me rename the kernel module from my module to my sysclass.c. And of course I have to change this in the makefile as well. Okay, so let's open it up. So here you can see the code for a simple Hello World Linux kernel module. So let me adapt this to the Linux kernel coding style guidelines. Okay, and yeah, that's basically it. And let's change the module description to a Linux kernel module showing how to use sysfs class interfaces. Okay, and the first thing we need to do is we have to add some header files. So I will need two headers here. The first one is linux/fs.h, and then I will need linux/device.h. Next thing is I have to declare some global variables. So we will need a device. So normally how you would do this, you will first create a class and then you will create devices belonging to your class. So for example, every LED you have seen is a device from the class LED. And then when you have created your device, you can add the files which are available to control your device. So first we will need to allocate a device number. Then we will create a class. And last but not least, we will create a device. And under this device, we will add multiple files. Okay, so first let me show you how to create all this stuff. So here in the init function, normally you wouldn't do this in the init function, but in the probe function, or it depends on the kind of driver you want to write. Okay, so the first thing we need is I need a variable I will call status to capture some return values. And then I will allocate some device numbers with the function alloc character device region. The first argument here is a pointer in which we want to store the device number, so this will allocate the next 3 device numbers. The second argument is the minor device number with which I want to start, and here I want to use a 0. Then I have to tell it how much device numbers it should allocate, and here I want to allocate minor mask +1. And the last argument is a name which will be shown in proc devices, and here I will choose my device. And in case the status is not equal to 0, an error occurred. My sys class error allocating the device numbers, and then I will return the error code here. Okay, so now we have created the device numbers, or a valid range of device numbers we can use. Now let's create the class. And this I will do with the function class create. And the only argument I have to give it is the name of the class, and I will use my class here. And this will be the name which will be shown under sys class, and then my class is the class. Okay, in case it returned an error pointer, an error code. So yeah, let's copy these 3 lines. Error creating class. Then I will set the status variable to the error code, and I get the error code with pointer error. And then I will go to free device number, and under return 0 I will create this label free device number, and what I will do here is I will unregister the device numbers I have allocated. So I want to free everything from device number, and I want to free minor mask +1 device numbers. Okay, but in case this worked, we have now created our own class under sys class my class. Okay, then the next step is to create a device. So my device will be equal to device create. Here the first argument is here is a class under which we want to create the device, and this is my class in my case. Then the second argument would be the parent device. So for example, if it would be in a PCI driver, for example, the PCI, or in the probe function we already have a device, and we can say, okay, the device we're creating here is a child of this probed device, for example, but as we don't have a probe device here, I will pass a null pointer. The next argument is the device number, which I will be using. So this will be minor number 0 and major number what we have allocated here. Then the next argument is some device data we can pass to our device, and which will be available in all the other functions, but as I won't use it, I will set the data field to null here. And then I have to pass in a name of the device, and I will name it my device and then %d, because here we can actually use strings like we would use in printf. So now the next argument is the number I want to add here, and this will be minor, so the minor device number. Okay, and once again I have to check if this returned a valid pointer, and if so, we have created the device my device 0 under sys class my class. Then device my device, and then free, and in case this fails I will go to free class. And what I have to do in free classes, I have to call the function class destroy my class, and this will destroy the class I've created. Okay, cool. So now I have created a device, so a folder under sys class my device 0, and now I can fill it with some files. So basically, what I have to do now is I have to add some attributes to this device, and every attribute can have a store and a show function. So when I write something to the file or to the attribute, the store function will be called, and if I read from it, the show function will be called. So let me give you a first brief example. So I will declare a new global string I will call text, and I will initialize it with hello world. Okay, and now I want to add an attribute to my device to manipulate the string. So how can I do this? Well, as I already told you, I need to implement a store and a show function. So let's start with the store function, which will be called when we are writing to the device. So the first argument is the device, and in case I would have allocated, or I would have used the data field here, so this argument here, this data would be available here in my callback function, but I haven't used it. The next argument is from the type struct device attribute. Okay, this should be a lowercase a, but I also won't use it. The next one is a const char string buffer, and this is a data I will write to my device file, and the last argument is the length of this character buffer here. So the cool thing is, this is not a user buffer. I don't need to copy this buffer from userspace to Kernelspace, so I can directly use it. So what I will do is I will declare a variable I will name to copy, and then I will check if the length is smaller than size of text. If so, I will initialize to copy with len. Otherwise, I will initialize it with size of text. So here I'm just making sure I never copy more than 64 bytes. And then I will just call string ncopy. The first argument should be the destination, which is text. The second argument is the source, which is buffer, and the last argument is the amount of bytes I want to copy, and this is to copy here. And then I will return the amount of bytes I have copied, which is to copy. Okay, now I need a similar thing, but in the other direction. So I need a function called text show. Now the string is no longer a const string, and we also don't have a length here. And basically everything I'm doing here is I will copy into my buffer. So I will copy the text into the buffer here, and then I will return the length of text, which are the amount of bytes I've copied. And that's basically it. Okay, and now I have to create the device attribute. And therefore I will use a macro. So the macro is called device attribute. The first argument here is the name, which will be given to the attribute, and I will choose text here. The second one are the read and write permissions, and I will use 660 here. So read and write from user or owner and group owners, no permissions from others. And then I have to pass in the pointer to the show callback and then to the store callback. And that's basically it. That's how you're creating a device. And now the device attribute I've created has the name device attribute under text. And the cool thing is, if you just want to do something like this for integer or bool values, everything is a little bit more easier. So I will declare a second variable here I will call answer, and which I will initialize with 42. And the cool thing is, Linux ships some predefined callback functions for changing an integer or bool value. So all I need to do here is I will create an integer attribute. The first argument again here is the name I want to give it, which will be answer. Then the read and write permissions, and the last argument is the variable which should be written or read over the callback functions. And this will create an object from the type def extended attribute, and this has not, so the struct def extend attribute has a field from the type struct device attribute and also a value field which is a pointer to this answer variable, and then it's using pre-implemented show and store functions. Okay, so we have created the attributes, but we haven't added the attributes to our device. So let's do this. So maybe let's start with the string, with adding the text variable. So therefore I will call the function device create file. The first argument is the device under which I want to add the attribute, and the next argument is a pointer to the attribute I want to add, and in this case, so this macro up here, this here created the created a structure with the name device attribute text, and this is what I'm passing here, a pointer to this. Okay, and once again, let me copy this error lines here. Error creating text attribute, and then I will go to free device. Okay, so here in free device I will destroy my device, and here I have, this is a little bit odd, I don't have to pass a pointer to my device. Instead I'm giving here the class under which my device is allocated and the device number. So over this the device is also findable. And then let me copy these 6 lines here and paste it in right here, because basically for the answer it's quite the same. The only difference is now the attribute is from the type def extended attribute. So the macro creates this struct here, and here I need to pass a pointer to the attribute part. The other field would be a value, but okay, and here error creating answer attribute text. Okay, and here I will use the function device remove file, and as an argument I has to pass the device for which I want to remove a file, and then the attribute, which is def attribute under text. Okay, and I forgot one important thing. Down here I have to return the error code. Okay, so the last thing I have to do is I have to implement the exit function. And of course I have to free the answer file as well. Okay, so that should be it. Let me try to compile it. And let's see how much mistakes I've made. Okay. Okay, requires 2 arguments. Yes. Not a problem. So in create class, I forgot to use this module. So the class belongs to this kernel module here, and the name should be my class. I think this should be the error. So let's try it again. Yeah, now it's looking good. And now if I take a look under this class, I have these classes available. And if I load the module and take a look again here, you can see a new class with the name myClass appeared. And if I take a look into it, we have one device available, which is called myDevice. And if we take a look what's in myDevice, we see we have an answer field and we have a text field. So let's see what's in here. First, let's read the answer. Oh, and of course I don't have the right permissions. So let's try it again. Yeah, and the answer is 42. And with echo, I can write a new value into it. So let's do this. And now you see the value has changed. And now let's do the same thing for the text. So here we have hello world written into it. And we can update it to this is my cool U clause or clause device to this here. And now if we cat it again, yeah, the text is updated. Cool. So that's how to implement a sysfs clause interface. I hope you've enjoyed the video and learned something. In case you want to support my work, you can buy me a coffee on buymeacoffee.com/JohnasForLinux. So that's for today. Thanks for watching and goodbye.